Today we're going to talk about section 6.4, properties of special parallelograms. All right? When you think of possibly some special parallelograms, what is maybe a possible shape that comes to mind?
Rhombus.
A rhombus. A rhombus is actually one of the shapes we're going to talk about today. What's another one that might come to mind? A rectangle. A rectangle is another one we're going to talk about today, and there's one other one that's a special parallelogram. It is, somebody said it. A square. Okay? Rectangle, rhombus, and square are the three special parallelograms we're going to talk about today and some of their properties. So section 6.4. First one here is a rectangle. A rectangle. Now, a lot of you might be thinking, yeah, we've been talking about rectangles for a long time, elementary school all the way up, your shapes. Yes, that's true. But there's some properties about it we're going to talk about today. Okay, a rectangle is a quadrilateral with four right angles, I should say. If a quadrilateral is a rectangle, then it is a parallelogram. All right, so all rectangles are going to be parallelograms. And if a parallelogram is a rectangle, then the diagonals are congruent. What's it mean to be congruent? Same. So the diagonals are both going to be the same. All right, so for all rectangles, the diagonals are the same. Nice job. Since a rectangle is a parallelogram, a rectangle also has all the properties of a parallelogram. So everything that's true within a parallelogram is true within a rectangle, which makes sense because a rectangle is a parallelogram. All right, we're just going to add these two parts to it here. The next one we're going to talk about is a rhombus. A rectangle has all four right angles. A rhombus is a quadrilateral with four congruent sides. What's the meaning of being congruent again? Same. So it has four same sides. A rhombus has the following properties. If a quadrilateral is a rhombus, then it is a parallelogram, so that's true. If a parallelogram is a rhombus, then its diagonals are perpendicular. This is a key one today. What's it mean to be perpendicular?
The cross, or the intersect.
Kind of. Tyler said it correctly. Tyler, say it again. Yeah. Notice, they intersect at a 90-degree or right angle. Does everybody see that?
Yeah.
So if the diagonals are perpendicular, that means they intersect at right angles. That is a key point. Remember that. And the next part here, if a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. What's it mean to bisect? So if you look right here, the diagonal cuts Q in half. If you look right here, the diagonal cuts S in half, cuts R in half, cuts T in half. Okay? And the last part again, since a rhombus is a parallelogram, a rhombus has all the properties of a parallelogram. Okay, 3 points. And the last one we're going to talk about today is the square. A square is a quadrilateral with four right angles and four congruent sides. So the square is both a rectangle and a rhombus together. Okay? So here's a parallelogram, which we've been talking about. A rectangle, four right angles. A rhombus, four congruent sides. And then a square, four congruent sides and four right angles. So you can see kind of how they're all related. All right? And again, all those are parallelograms. So let's try out the first set of questions here. All right, these three. Now again, you cannot say, well, they all look like they are squares. Okay, it says, tell whether each figure must be a rectangle, rhombus, or square based on the information given. Use the most specific name possible. Again, could you say probably all four look like squares? Yeah, but I cannot say that for certain. So let's look at number one. I know that number one has all right angles. That tells me number one is for sure what, Reed? That is for sure a rectangle. So number one, I would say, is a rectangle.
Number 2 is a square line, right?
Number two, I have four right angles and all the sides are the same. Trent, what do you say? That one's going to be a square. And three, Brock, what are you thinking on three? Rhombus. Oops. Again, make sure you know what information is given. You cannot just assume or say it looks like this or that. Make sure you know it has to be given to you to determine what it is for sure. So rectangle, square, and rhombus there. Using the following rectangle, answer the following questions. Okay, using the rectangle to the right, find the following lengths. Take a couple seconds, try these 4 on your own. As I look at this, number 4. Quinn, what do you think about number 4? BD. What's BD going to be? What? 13. How did you get 13? I agree. Yeah, this side's going to be 6.5 as well. So 6.5 is 13. Nice job. 5, CD. Audrey, what's CD going to be? 5. How'd you know that?
Because BA is
Same as BA, right? 6, I need to find AC. Katie, what's AC going to be?
13.
How you know that?
Because it's the same as
AC is going to be the same as BD. Diagonals are congruent in a rectangle. Nice job. And last one, 7, AE. Let's go with Chris. What's AE going to be? 6.5. Nice job. All right. Next one here gives me a rhombus. It says KLMN is a rhombus. Find each measure. Take a couple seconds to try these 2 on your own. Now, notice, remember it's a rhombus. So what do you have to know to be true in the middle of a rhombus where the diagonals intersect? What's true about that? They are what? Right angles, which means how many degrees? 90. Remember that. Take a couple seconds, try these 2 on your own. All right, number 8. Let's find KL here. Well, if I were to find KL, which is this side right here, what's KL going to be the same as in a rhombus? It's going to be the same as MN, which is also going to be the same as LM and KM, because it's a rhombus, all sides are the same. So, Colin, how do you set that one up? 3x plus 4 equals x plus 20. When you do that, you get x equals what, Colin? And then you plug it back in, and KL is going to be what? 28. Nice job. Gentlemen, quiet down over there. And then 9. Now we do number 9. One of the things I mentioned was, remember, in a rhombus, the diagonals are perpendicular. So, Trent, what do I set 9y equal to? Yeah, I'd say 9y equals 90. When you do that, you get y equals 10. Now I take y equals 10, I plug it in down there. And what's that angle going to be? 25, which means what's my angle going to be then? 50. My answer is 50 degrees. Nice job. So again, recognize there are some problems. You might need to do some additional work for the properties as opposed to just finding what the answer is right away. There's some work involved using the properties. Last thing we're going to talk about today is pay attention and listen up. You can show, using the coordinate plane, that certain shapes may be not only parallelograms, but squares, rhombuses, or rectangles. Okay? To show that the diagonals of a square are congruent, perpendicular bisectors of each other. What's it mean to be perpendicular? 90. What's it mean to bisect? Cut in half, right? So to do that, I'm going to find the distance. I'm also going to find the slope. And then I'm going to find the midpoint of the diagonals. And guess what? My distances should be the same. My slopes should be opposite reciprocals. And my midpoints should be the same. And that's what tells me they are perpendicular bisectors. Okay?
Wait, so you do the slopes of the lines?
Yep. So the slopes of the diagonals. So I'm doing the diagonals here.
Slopes of the LK.
Because that doesn't tell me for sure if it's a square. It's easier to do the diagonals. You don't have to do all 4 lines. Okay? So again, what we're doing here, we're finding distance, slope, midpoint. Don't we do that on a regular basis anyways in our warm-ups?
Yes.
Yeah, we do. Okay? So, let's look at number 10 here. The vertices of square JKLM are J is negative 2, 4. K is negative 3, negative 1. L is 2, negative 2. And M is 3, 3. Find each of the following to show that the diagonals of square JKLM are congruent perpendicular bisectors of each other. So we're going to look at points JL and KM. So I'm going to write them down here for us, and we're going to find some work here. So JL, J was negative 2, negative 4. And L was 2, negative 2. K was -3, -1. And M was 3, 3.
For J, it's positive 4, not negative 4.
What was it?
It's positive 4, not negative. For J.
Oh, thank you. And M was what, 3, 3? So if I have the coordinates here, can I find the distance of those coordinates? Yeah, can't we just use the distance formula, right? So I want you to, on your own, take a couple seconds, find the distance of these coordinates, find the distance of these coordinates, then find the slope of each and the midpoint. Okay, so take a couple seconds on your own. Find the distance, the slope, and the midpoint of both of those. All right? Take a couple seconds to finish those on your own. Jake O'Connor, JL, what's the distance for JL? It is 2 square root of 13,
They put it.
which is the square root of 52. If for some of you other ones that didn't, so that's okay. Square root of 52 is fine. Simplify if you can. 2 square root of 13. Good answer, Jake. Jake, what's the slope there, bud? Jake, what's the midpoint? All right. Becca, give me the other one. KM. What's my distance for KM? 2 square root of 13, or it also was square root of 52. What's the slope, Becca? 2 over 3. Midpoint, Becca? 0, 1. As I look at this, are my distances the same? Are my slopes opposite reciprocals? Are the midpoints the same? Is it a square? Yeah, it is. That's what we're talking about today.
Oh, we're done?
So one of the businesses.
Here's your assignment.
One of the businesses.
There's your assignment.
One of the